Hello everyone, and now we're going to be doing example 9-17. Okay, this one has something that's a little bit different. We have a hollow tube that we're working with. So what it says is a tensile member in a machine is subjected to an axial load of 5,000 pounds. So we have this member. It looks something like this. It is hollow, and it has a load of 5,000 pounds. Once again, 2 arrows, 1 force. Okay. Has a length of 30 inches. Is made from a steel tube having an outer diameter of 3/4 inches and an inner diameter of 1/2 inches. So, 30 inches here. Outer diameter, which is 0.75 inches. Inner diameter, which is, what was it again? 1/2 inch. Okay. It says compute the tensile stress in the tube and the total axial deformation. It says assume an modulus elasticity of 30 million psi, so it's probably steel, and a proportional limit of 34,000 psi. So, let's try it out. The first thing is, let's write down our givens. So our givens are the load is equal to 5,000 pounds. Modulus elasticity was equal to 30 million psi. The outer diameter, what d out, we're going to say is equal to 0.75 inches. The inner diameter is equal to 0.5 inches. The length is equal to 30 inches. We're given so much information. It wants us to find the stress and the total elongation. So, first things first, let's calculate the area. So this time the area is going to be the area of this surface right here. So we're going to have a big circle, pi over 4 d out squared. Then we're going to subtract out the inner circle, pi over 4 d in squared. And so what that's going to give me is an area of 0.245 inches squared. Now, before I go on and start trying to calculate the total elongation, I'm going to go ahead and check to make sure that this is below the proportional limit, because that was given to us. So the proportional limit, I'm going to say stress pro, is equal to 34,000 psi. We can only use that Flee equation, or Plee equation in this case, if it is below this. If it's above it, we can't use it. So let's check. Stress is going to be equal to the load over the area, which is going to equal to 5,000 pounds over 0.245 inches squared. And that's going to come out to be exactly 20,400 psi. Okay, this is less than 34,000 psi, so we're good. We're good. We can use our Plee equation. So our Plee equation to get the elongation is PL over EA, which is equal to 5,000 pounds times 30 inches all over 30 million psi times the area, which is calculated earlier as 0.245 inches squared. And if we plug all that in and hopefully did it all right, that should come out to be 0.0204 inches. And with that, we have our answer. This is the total elongation, and this is our stress right here. So we got the answer. Just remember that if you're going to be using this equation right here, the Plee equation, the elongation equation, you have to be less than the proportional stress. Now, most problems it wouldn't give it to you or ask you to do it if it wasn't going to work out to be less than the proportional stress, but not always. Sometimes they like to be a little bit tricky and make you realize you have to go find some table somewhere that shows it. Shows the stress-strain relationship without using these equations. So be careful. I'm not going to try to trick you, but it will be something you have to think about. Well, I hope this helped you, and I will see you in the next example.